Welcome to Dialogue, a podcast where we unravel the threads of technology that are shaping the future of our world. We discuss technology and software both on high level and under the hood.
My name is Lauri Utila, and I'm the CTO at Finitech, the leading freelancer tech talent agency in Finland. And I'm your host on Dialogue, where I'm interviewing top professionals in their fields, so as a software expert, you might not want to miss this. Welcome to Dialogue. Today I'm speaking with Andrzej Krzywda. He's CEO at Arkency, a well-known software development consultancy from Poland. They do work on Ruby on Rails and big projects. Andrzej's been in software development for over 20 years. He is author of many books, writes a popular blog, and I'm excited to have him on because I think Andrzej and his team, they have really unique and refreshing ideas about software development regarding event-driven architectures, moduliths and microservices and so forth. So I think you're going to enjoy this conversation with me and Andrzej. Welcome to the program, Andrzej.
Yeah, thank you. And hello, everyone. Thank you for the introduction.
So if you want to give a couple of words why people should listen to you. So what's your? I already gave you a little bit of background that you have, but anything else you want to mention to the audience?
I've been on a kind of a journey in the software programming world since 2000 year, and even before that, when I was very young, I was helping my parents with their business. So I was on the other side of the tech world because I was actually ordering dedicated software for our business. So I saw programmers working for our needs. And then I started programming and I went through all the technologies possible, starting from Java, .NET, PHP, Python, and so on. But I stick to Ruby on Rails, and this is our business niche with Arkency. And Ruby on Rails is a technology that is very similar to many other web technologies like in Java, Python, or PHP. So there's not like huge differences now. And we try to rescue big Rails projects. We try to rescue them because if you follow the CRUD, paradigm too much, the database-oriented development too much, and the framework infection too much, then you get somewhere you hit the wall, and it's not really great when the business has to wait for the programmers to clean the technical debt or modularize the software a little bit, or basically just get rid of some bugs, or not getting back to the same bugs over and over. So that's my quest, to find and research certain areas, like how to improve it. And that's never a finished story, right? So it's still ongoing, but I am happy where we are with Arkency. I'm happy what we did with Rails Event Store. So we have an open source implementation of an event store based on a normal relation database, and we introduce some techniques how to use event-driven architecture within Ruby on Rails projects.
Yeah, so that's one of the main reasons I wanted you on, because a little bit of a personal journey. I've been following you for many years now, reading the Arkency blog and following your YouTube channel, which has a lot of good material for at least for Rails developers, but for any developer for that matter, in my opinion. And so maybe we can put the links on Andrzej's YouTube channel in the show notes. And a couple of years ago, you guys came up with the Rails Architect course. I took that personally and found it to be really helpful and got exposed to the ideas of, as you said, moving beyond CRUD in Rails and in web applications in general. And so I guess we could start with the craze that has been maybe subsidized a little bit, but let's say 5-6 years ago, there was a big push towards everything being microservices. And a lot of companies invested a lot of time and effort and manpower to transform their current applications or the stuff that they were building, the greenfield projects, into microservice architecture. And some of them learned the hard way of different different challenges that come along the way. And like my personal observation back then was that the too many companies or software teams, let's say, went head on to the microservices world when they really didn't need to, and they could have get by with regular majestic monoliths that people, at least in Rails world, built under the, well, let's say the founder of the framework preaches on. But what's your take on like microservices architectures, and when do you think they are useful, and when do you think you should definitely not look into that?
It's a huge topic.
It is, yes.
I think there are like many motivations to introduce microservices. Some of them are correct, maybe. I mean, within huge organization, the temptation to introduce microservices is big, because it does bring some organizational split, which helps running and managing the teams, running and managing the project, split it into maybe several sub-products or sub-projects. In general, I think many projects and many companies, they fall into the same trap. They go microservices before solving the modularization problem first. So they think they found a good split. They found good boundaries where to split along. And usually, unfortunately, it's not the case. And once you make the split, it's not so easy to refactor. It's not so easy to move responsibilities between the microservices, to change the boundaries, basically, because you need to move the tests and so on. It's a little bit difficult. While I think what they are really usually looking for is modularization, and it's some way of having a decoupled architecture, a loosely coupled architecture. So a way of developers working on certain modules without breaking the other modules. So with microservices, the one additional point that people receive, or maybe two, is that, okay, the deployment is separate. That's completely isolated. That's a big gain. So I will not argue with that too much. That's a gain. But without microservices, you can get very close to this as well. Like, okay, you will not get separate deployment, because that's by definition in the monolith there is no separate deployments of pieces. But you can get like separate continuous integration. You can have separate tests running. You can have separate certain checks on the software. So you can get quite a lot even without going so far as to microservices. And the cost of microservices is like huge, the obvious one. So now your data needs to be like constantly serialized and deserialized, because it has like every connection has to go to several microservices. And usually, if you actually have a good modularization and then it's followed by microservices, then it's usually fine, because a good modularization means that there's not so many cross dependencies between modules. And but if you go with wrong modularization, then you have situation where typical web request goes to several microservices. They depend on each other, so there's no isolation. There is no the microservices are not autonomous. It means that one microservice is down, actually everyone else can't really work because they have to access the data from this microservice. So those are the problems, and I think the solution is to first focus on modularization, only then maybe consider microservices for organizational split, or I don't know, you really want to have separate repositories for some reason. But still, for example, I see many projects going into this direction of microservices, but still having one repository, which is, I think, still a better situation than having separate repos for everything. And the scalability, okay, that's a good argument for microservices, where you really need some piece to be scaled more than others, and maybe there are some runtime costs around for that. But again, without good modularization, you will not really scale very well. And there is like this programmer's favorite argument for microservices, that now we can write we can learn new languages, basically. So we can write some Haskell, we can write some Rust, we can write some Go, Scala, whatever is the fancy language of the year. that's an argument for keeping the programmers' morale high. That's an argument for recruitment, maybe. Actually, I've seen this as a recruitment argument. So yeah, but this is not a rational argument. It's more like emotional argument here.
Okay, so how would then one go about achieving good modularization? How would you advise people get started with the?
Yeah, it's this is like the topic I researched for like 20 years now, and I don't think there is super like silver bullet answer, although I like those ones when there is one. But from my quest, I researched many different like paradigms. So okay, let's first object-oriented versus functional paradigm. Okay, that's the clear one. But this is usually not the biggest importance, I would say. I like both functional and object-oriented. I don't think they can be matched. They can be combined sometimes. But that's not the modularization level, I would say. It's more like the tactical level. And then, okay, I tried things like, when I was still in Java, I tried aspect-oriented programming because basically in any business software, you have the concerns and you want to separate the concerns. Ideally, you have a module per concern, but there are cross-cutting concerns. So aspect-oriented programming kind of solved this problem of cross-cutting concerns. So that was my area of research. That was actually my master thesis to using aspect-oriented programming for separation of concerns. But actually, before you even try to capture the cross-cutting concerns, it's important to capture the business concerns, I would say. And the more I researched, I tried also researching data context interaction, DCI. This is like a really academical architectural approach, but still this wasn't very practical. And then I realized that there is already this community of domain-driven design, and they bring you a good foundation of thinking that, okay, at least that's my main understanding of domain-driven design. This is all about following the business in our code base. So trying to follow what is the structure of the business in the code base. And even more than that, following what the business should be, and try to capture that in the business, because sometimes the business is actually very small. There's like one department or two departments, and that's it. But in the code base, maybe there's more, because we want to capture like things like, okay, let's be specific, like pricing or ordering or invoicing or billing. Those are the typical departments in the company. Sometimes one person does it, right? So the roles are not really split at the business level, but they could and should be split at the software level, I believe. And then when you have this kind of matching between the business concepts and the software, the code you're writing, so the domains are captured as modules, then it's already an improvement, because then you start speaking the same language as the business people. So we are actually talking about this phase earlier, not only at the code level, but when we receive requirements or when we try to dig the requirements deeper, we need to communicate with the business. And okay, what language do we use? So for example, I always have this joke that it's already over when the business people, they speak the CRUD language. Then it's over, because it's actually a situation where the business people, they learned that programmers use this create, we are just updating this record and we're creating this object. So the whole, it's like using the English language, but be limited to just create, update, destroy. You can do it. It's like it's a full algebra or of vocabulary. But the business is more nuanced than creating, updating, and destroying. And this is the nuances. That's what we are talking about. So we should try to understand the business with their words, and then use their words and put them in our code base. That's a tricky part, and it's not easy. And for example, one big thing that domain-driven design brings is that, okay, in one domain, let's say in pricing, the product means something different than the product in, let's say, inventory. Those are two different areas of business and completely different life cycle. Completely different way of managing the inventory. Can think more about packages of stuff, while the pricing can also think about, okay, we can have some discounts, we can have some promotions, we can have some pricing windows, we can set prices for the future. So it's completely different understanding of what a product is, while it's still a product, it's still the same. And in DDD, in the end, says we should have different product classes for those two different modules. In domain-driven design, we call them like, okay, if you map a domain into code, we call it bounded context. And this bounded context becomes this module. And basically, when I say pricing, I mean like module pricing, or if you're like programming language, again, in Java, it will be a package. In Ruby or Python, there will be a module. And yeah, you should have a namespace for that. And then within this namespace, you have different meanings for certain classes. And ideally, those two modules, they don't talk too much about each other. Ideally, not at all. But okay, we are not living in the perfect world yet. So at least to reduce the talking between those components, between those modules here.
And would you say that if they need to talk to each other, they wouldn't talk directly, but through maybe events, or how would you describe the necessary communication that might happen between the two modules?
Yeah, so this is where I think there is a little bit of a limitation of what domain-driven design brings to us. I think at least the classical meaning of domain-driven design, as from the Blue Book, the Eric Evans book, when it was introduced, it was a lot about this strategic pattern. So the strategic pattern is basically, in my understanding, that's mapping the business into the code base at the structure level, so the modules. But it doesn't really solve, I think, the DDD on its own doesn't solve the wider part of the system, not only the domain. So domain-driven design focuses on the domain part. And it's already huge because the tools it brings, value objects, aggregates, process managers, those are huge and super important. But to me, they solved certain complexity in my projects that I've seen, the typical web projects. But actually, because we mostly work on web, right, nowadays, in 2004, when it was introduced, web wasn't like the biggest one, probably. So it doesn't solve the application layer part. It doesn't solve the UI. It doesn't solve the let's stick to this. So the UI, all the views in our web, which also kept changing in the web industry, as we tend to just render the HTML on the server, but then there was a big revolution, and the front ends kind of liberated themselves, and they become their own applications with JavaScript, and they asked for the data with some kind of AJAX calls. So there were changes, but I think DDD, that was, at least for me, that wasn't enough. And basically, if you just introduce domain-driven design, so you would have those business objects, let's say this product class in the pricing module, and you want to display a product card, or so you want to display the product page, so the product where you just see an e-commerce and there's a product page. And you don't want to display only price. You want to display the product name. You want to display maybe how many pieces of this, how many items of this product are available. So the availability part or the inventory part. Maybe you want to display some tax information on this product. So that's like a taxes domain. So in the end, what is happening is that the UI needs to talk to each of the module and just make a query to one module, make a query to another module. That would be the primitive approach. And by the way, that's often the case, like with how people implement the microservices, they could end up with something like this. So maybe they will go with some kind of DDD approach to split the project into pricing, ordering, invoicing, shipping, and stuff. But then you need to show it to the user. And then the dance of the microservice starts happening. So you need to ask this, and somehow join the data, right? And there's like all the serialization around. There's all this OAuth, authorization part. So there's quite a lot of overhead that just coming from the fact that we are doing network calls. But even if you do it as part of the same monolith, so it's all part of the same runtime, it's still, I think, not very perfect. So I was looking for a solution. Okay, how we can solve this? So then I found the Greg Young lectures and materials, and basically he's the person who invented or discovered or described what is CQRS. And the main part of CQRS is understanding that reads and writes are different to the system, and it's amazing fit for domain-driven design. because it solves, like, the idea of reads is basically that you will have a concept of read models. So the product page.
Now, before you go explaining, can you say what is a CQRS for the audience that they get the acronym?
Okay. So the acronym means Command Query Responsibility Segregation. It's a bit difficult name. So command and query, we try to split the system into certain, segregate the system into some responsibilities. And basically it means that we are calling the system either with a command. So we want to change certain things. We want to say to the system, please change the price, or please order this product. Or we send a query. A query is, for example, please give me the product page. So that's the high-level query. And the commands, they could be like high-level commands or low-level. Okay, the granularity can be different, but usually the commands are at the domain level. So you say to the pricing domain, you say, hey, we have this product ID, and the command is like a data structure. So we have this product ID, and we want to change this product ID to a different price now. So let's change it to $10. So that's command. Queries are simple. You could imagine them as method calls. So like, okay, just show me the product page, right? Just give me the product page, however it works. And the commands as a data structure, this is just a little bit of code, additional code. You don't really even have to be so explicit to have this as a command. It can be just, a facade on your system level, or at your domain level, like what is possible to do to change in the system. You have just a number of methods to be exposed as a public interface. The most interesting part of CQRS to me is read models, because it solves exactly the problem which I said, of grabbing, okay, I want the product page, but I need to grab information from many different sources. And they reverse the flow. That's the solution with the CQRS, and that's the solution with read models. And that's the solution that at first many programmers don't like, because reverting the flow means denormalizing the data. And that's the part where people get a little bit stressful, because denormalizing data means a necessary need of also ensuring that data is synchronized. So because denormalized data means data duplication. And we all are taught at our universities, boot camps, about how to have, the actually normalized data. So how to keep one record for like the whole thing, because then you can join the data, and that's actually the beauty of it. So the read models, they kind of go against it, and they also can be seen like a little bit of a cache. So programmers are familiar with caches, and again, if you say them that this is a cache, they will immediately think, okay, but cache invalidation is like this super difficult problem in the software. So that's true. And how do you synchronize? That's the important part. How do you update the read model? So let's say we have this very simple product page. It has a product price and number of items available in inventory. So 2 informations only, just for simplicity. And what kind of information do we need? We need, whenever a price is changed, we need to know it. So that's where the events part come in. So we basically declare so the read model actually becomes a module. It will have its own little database, but it can be only conceptually database, like a separate database. It can be like a part of your normal PostgreSQL database. It's just, we will have some namespace tables for this little part of the system. So the product page will have its own products table. And whenever product price is changed in the pricing module, the pricing module will publish an event called price set or price changed, with the ID and with the price. And the read model can subscribe to this, which means it will be notified that this event arrived, that was published. And if we keep it as part of one monolith, that's almost like in memory. The events are just flowing through the memory. If you're using something like Rails Event Store or something similar, the event is first persisted, then published, to just keep things robust here. And the event is published, and then the read model says, okay, so I will update my product record to say they have a price. Even before that, the read model can or cannot, there are different patterns here, can be notified that actually product was created. So at least it knows the product exists and then the price was set. But that's a matter of certain granularity. And the similar situation will happen with whenever the inventory data changes. So whenever product was bought, from the inventory perspective, it's actually the stock level changes, the quantity changes. So you can have an event like product quantity increased or product quantity decreased or something like this, and or stock level changed. And you will publish an event. A read model will just grab this data. Okay, so I will just -1 the item in our, like the counter in our product page. So the read model has no logic, not at all. It's just a pure reaction to certain facts that are happening in our system and updating certain records. So basically, read model is a data structure, which is implementation details that it's just persisted in data table. So it works as a cache because it's only changed during the changes in the system. It can be asynchronous. It doesn't have to be synchronous. It can be asynchronous. So in Ruby on Rails, we would use Sidekick for those changes, or some kind of background jobs. And then it's super fast because you don't join any data, right? Even some people go to the point that they don't persist them as the data table, like you would imagine SQL, but they would persist it, let's say, as JSON immediately. Oh. So even when it's persisted as JSON, when you retrieve it, you already have JSON there. So no JSON serialization time needed because it will happen before. So it has all the beauties of a cache, but without this problem of cache invalidation, because the cache invalidation is not really cache invalidation. It's more like cache changes applied via events. So there's like very specific algebra what can happen and when it can happen. And obviously there are some problems to solve. Like, for example, if you use those Sidekick or something like background workers, you cannot rely on order anymore. So you have to be careful. Maybe the price changed event will appear faster than product created, and you have to deal with this. But that's easy. That's just need to write some tests and prepare the read model for such situation. And if you do this for all the important views in your system, so all the important views in the system become those modules, those read models, and they will have their own data tables only for them. And we only use read models from the web controller level. So we just say, okay, give me the data from the controller. So the user clicks on the on the product page, and we just go in the controller, we just go immediately product page dot all or product page. Okay, so product page dot get me first the ID of this product and get me the JSON immediately, right? So it will, because let's say we agree on this JSON serialization in the database, and it will just get the JSON. Or if we, like, for example, now in the Rails world, we are coming back to this hotwire part and update, like rendering the HTML again on the server side, which I think is also an interesting idea to be back in our environment. Then you can keep HTML, or you keep SQL because the rendering is maybe not as painful for your case. So this is like more optimization techniques now. And what's important is that we now have the domains, the pricing, the inventory separated. Very easy to unit test because they will react to commands as the input, and their only output, if you do it right, is events. Commands, events. So basically there are functions. So now this is like I link to the functional people. You can implement this as functions. So the domains can be very functional. Actually, you can make the domain being event source. I'm not sure if we want to go into that. Event sourcing is basically left fold in functional programming. So you grab a series of events, you left fold it, and then you have an object, the last object state. And that's what databases do for us under the hood anyway, usually. So that's a normal pattern. And then you have actually modules for everything. So now it's very like read domains are commands inputs. Read models are events as the input, some kind of data structure as the output. Very easy to test, very easy to implement. And also at the high level, it's something when you can show it to the business, what is our architecture about, they understand it. They understand the events because it's like certain important business change in the system. They understand what they see, so they understand the read models, and they understand the business concept. Like, okay, they understand there is an invoicing department in the code base, right? So that's, the whole communication now is kind of more smooth, and the code base is cleaner too.
Well, there were quite a lot of let's say big ideas also you touched upon first, but now that you broke it down to that example, it sounded like that getting started with it wouldn't be well, it might be difficult in terms of like grasping the new concepts and so forth, but what I'm hearing is that you don't have to make like, it's not a binary decision to start doing DDD or start doing CQRS or event sourcing, maybe event sourcing, but publishing events and reacting to them. And am I correct that like one place where you could start is by implementing the read models, and that would be also already a good step towards modularization and in your journey towards this kind of a development approach or the structuring architectural approach?
Yeah, exactly. I think that there are many strategies how to start without going all in, but the most pragmatic one is starting with read models. I see this as the best solution, as the first step. So you don't have to go all in with extracting domains, finding boundaries for your bounded context. You don't even have to go with the events yet. And that's because with the read models, like there's no disagreement. Like you look at the page and you see, okay, like usually you have like this main page, what is visible. So that's the product page. Maybe you have like a little widget somewhere and to show, I don't know, something else. So those are like two different read models, just happen to be presented on the same page. So it's the number of read models is a little bit more than per page only, but it depends on how your UI is built. Sometimes your UI is basically one read model basically shown. Anyway, you can imagine this read model implementation. So let's forget about events. Let's say we don't have events. And I told you that events are the main input for read models. But what can be another input? Like events are just a way of controlling the flow. And this is like the most loosely coupled way. So with events, you just have a list of subscribers to notify when something happens. So it's basically an observer pattern in the end. But the other way to do, a bit more cumbersome, but at least you don't have to introduce too much at the beginning, is to find all the places where the read model needs to be changed. For example, in Ruby on Rails application or many other web apps or web technologies, you will have a concept of service objects, so the service layer. So at the service layer, you can do like stuff like, okay, I'm changing the price of a product, and then I know that there are 6 read models related to showing the price in our application, because one place can be showing the product on the admin panel, another place could be showing the product as a product page on the list of products on the public website. Maybe there is the order page where you also show some product information. So you will just, in the service object, you just say, okay, those are the 6 places which I need to call. So you call product page dot change price, and you will pass the arguments. Again, no logic in the actual implementation of the read model. You just, instead of receiving an event, you receive a method call, but at the cost of a little bit of coupling. So now your service objects need to know which read models they need to call directly. But that's manageable. So at least this requires the initial step that you know which places can change the price, because then you need to know, okay, where is this place we have to notify read model. So this may require a little bit of refactoring sometimes to make one place for changing the price, even if without going all in with boundaries and bounded context and so on. So then you still have like all the beauty of read models, and then that's the first step. And then if you are, because what's the biggest problem of introducing those techniques is to get the team familiar with it. So it's important to go step by step. And starting with read models is a really big gain. So I would even start with some reports or pages which are super slow, because that's easy to sell to the business. We want to say, okay, we will try to or sell to the business or sell to the technical team. Let's try to solve this specific speed problem, performance problem. And it's very typical, because when you show some reports, there are many joins and it's always slow. So let's try to turn it into a read model already like optimized for this kind of view. And then you have, in one area of your system, you have these people can get familiar with this pattern. And then, add new read models. And maybe then instead of having those 6 read models to call, you will say, hey, you know what? I will have an event now. I will publish the event, and those 6 places will subscribe to event. So that will be the flow reversion here. Yeah, but that's read models as a great start. It's a great start not only because of modularization, but because you can actually attack performance problems this way.
Now, you touched a little bit upon something that might be maybe the biggest challenge in adopting new concepts like CQRS and domain-driven design is, let's say you are a lead architect on the project and you subscribe to these new ideas, and maybe you've got some background in proof of concepting them, and you feel comfortable that they're going to be a good fit for you in a project. How do you get the team buy-in, and what would be like your suggestions on going about what kind of training they should be provided? How much does it take for a developer usually to get familiar and ultimately productive in these new concepts? Because from personal experience, I know that it, at least for me, it took quite a bit. Like I had been, I was suffering from the. I don't remember what was the term that you used regarding framework, but like the CRUD thinking, it's so pervasive that you kind of have to unlearn new things to learn new concepts. So how would you introduce this to a development team that's new to these concepts, but you think that they might be able to or you might be able to use this effectively in your project?
Yeah, as you said, the CRUD thinking or the framework infection, for example, that they always use this term, framework infection. So there is like the team is infected basically, and the code is infected. So too much reliance on the framework and trusting that the framework can lead us always, and we can follow the framework rules. The Rails doctrine is one example of this in the Rails world. So yeah, there is a big infection. I know what I'm saying is a bit controversial because, like, for example, in the Rails world, like that's normal that you follow the Rails way, the Rails doctrine. That's everyone follows this. But I've seen enough. Like I've seen hundreds of projects, and I've seen like how they all hit the wall at some point. So I don't really buy this argument that you can just follow the convention and everything will be great. So how do you sell it? It's a hard sell. I mean, it's very difficult. Like if you have people believing emotionally in like the framework way, that's years of unlearning, and that's year of curing the. Basically, you have to cure from the infection, and maybe you need a vaccination as well. Like maybe you need to prepare that it doesn't come back at some point. So this metaphor may work a little bit. Okay, so assuming like from which way you want to start, let's say every project has some problems. Like, okay, the team is focused on certain area, regardless of whether they are Rails believers or PHP CRUD believers or something else. The truth is there are some problems. The problems are visible from the business perspective, and there are. If you look at the backlog, you can see, okay, we are now in the next weeks we have some problems to solve. Or if you look at the quarterly plans, you see, okay, now we are solving these problems, for example, as the big ones. And the best way, at least to justify certain changes or justify some new approaches, is to try and choose one of those problems. So, for example, with performance problems, and very often you will see some performance problems on the backlog, it's very easy to introduce read models. But it's if you don't have performance as a problem, then maybe you need to change the strategy, maybe not going with the read models because there is no immediate gain from that. Maybe the problem is that, yet another time the programmers miscommunicate with the business people. They misunderstood each other. One technique which is useful to get everyone on the same board, and the business people and the IT people. It's so-called event storming session. So you try to put the developers team and the business team together in one room, or if you are working online mostly, then together on one Miro board. And if you have a facilitator who knows how to run this, they will do the job of trying to, like, the big picture events. Like, there are many kinds of event storming. The big picture one is like the introduction one. So big picture event storming is about visualizing the whole system, both from the business perspective and the tech perspective, as like a series of events on the wall. So you will use post-it notes to come up with as many events as possible in the system. And that's actually the first phase of the event storming session, of the big picture session, that you want to give everyone the post-it notes and everyone receive a pen, and you have a clear space on the wall, big space on the wall, or a big white table, a whiteboard. And you want to encourage them that, okay, what were the recent, like for the programmers, what were the recent area that you worked on? And please use the events, like, okay, what is the important business change in this area? So the price changed, or the order was delivered. They should be able to do this after a little bit of introduction, what is an event. And then you also want the same from the business perspective. So the business perspective will use usually slightly different language, but if I understand they are able to understand the semantics of an event, what it means. And they will try to use. And it's funny because the business usually concentrates on the money flow, while IT goes usually into some very details, very edge cases stuff, like very tiny events. And at the beginning, you just want to allow them to express themselves freely on this use. It's a success if most of the people you actually add some events. That's already a success, because we know with programmers, it's not so easy to sometimes get them in front of other people, do certain stuff. But it's nice when they collaborate, when they have this safe area to put a note. So there's not no wrong event, just put, even if it's duplicated, like add an event that is important for you. And then we have this next phase where the facilitator helps us to put those events in certain order. So we try to put the chronology from the left to the right on the system. So that's one phase. The second phase would be, now there are many different techniques. I was facilitating certain event stormings. So I was just like watching, okay, how the team behaves would be the most, where it makes sense. Whether we have activated the dev team first, and maybe business is too silent. So if business is too silent, I would say now we want to add a different kind of node. So we will have a different colors of the nodes. Let's say yellow will be events, but green ones would represent money flow. So when the money changes its owner, right? So we want the business people to show us where is the place where we make money, where is the profit place, or where we lose money in the company. We're using the events, and we just mark it with a green card that here is an important money flow. So that's already some certain area. Then we can also slightly regroup those events, because sometimes the flow is from the left to the right, but it's happening in different departments at the same time. So the price changed, but the quantity has changed. So we are adding those boundaries for inventory, pricing, and you can see how different domains, they have different life cycles. Sometimes you just, in certain businesses, the inventory is basically that something is always available. So at the start, you make a product available, and it's never like you sell ebooks. So it never really finishes, and it's never empty. And the inventory part is like it's always available. In some businesses, this is actually the biggest part, because it can be out of order, out of stock, and so on. This is the technique where you start introducing the event as the communication technique, and that's a way at least to improve the communication between the programmers and the business. And also, we would like to have the programmers use it in the code base. That'll be the next step. It's a big step. But if we are solving the miscommunication problem, we want to be very consistent with this. And if the business calls this event such and such, we want to find the place in our system where it's happening and publish an event using some kind of event store or whatever technology, or even just write your own at the beginning. Because at the beginning, you just want to publish an event, add some attributes to it, declare a schema of the event, at the beginning, you don't do anything else with this, because at the beginning, you just want to get used to this idea that we are publishing events. So you go with small steps. And the idea is to have this vocabulary from the business. Then obviously the next step would be to react. So, okay, whenever the price changes, we need to notify someone in the business that the price has changed, and they will receive an email or a notification. So, okay, so you're subscribing to this event, and then you can do something. So at least having the events in the system, even if they are just like no actions and they are not really costing that much, it's like one insert to the database, then new requirements can come. And for example, this notification requirement. And now the programmer can use this fact, okay, we have an event. We can add just a new event handler to send an email, and that's it. I will implement it. So now your code base become more an event-driven. And still, you don't have to think too much about the domains. You don't have to think too much about the read models yet. But this will be like a habit creation technique. So you want to introduce the habit that we have events per change of a system, and you want to introduce a habit of relying on this event. And if you're using, for example, like Rails Event Store or other event stores in other technologies, usually they will provide you some nice UIs or nice tooling for showing the events. So for example, just adding the events to the system is not really just an empty action. It's very useful for customer support. So you will see, okay, so what did the user do? What is exactly the path that the user did? And if everything is captured as an event, you just see a series of events related to this user, and you can either recreate the flow as a test scenario, or just easier for debug. You can see, okay, what were the actual calls. So it's like a log, but at a business level. So it's like a business log, basically, or event log. So for example, Rails Event Store comes with this event browser, a really nice thing that we can traverse the events. You can see what was the reason the event was triggered, what are the attributes. You can click around and play with this. So that's useful. You will have a new a new admin panel where you will see all the event flow. So this way you can also try to introduce the events. So that will be the more business perspective, right? Maybe you're solving the problem of the miscommunication at the business level. So that's like two examples. Read model as attacking the performance. That would be a nice way of introducing this, because with performance problems, for example, what options do you have? You can try to optimize some code, maybe some, but usually at the end you have usually there is okay, this join of the huge tables is too big for us, and we need to introduce a cache, for example. But cache it's really difficult. It's a different technique. It's slightly different, but it's different. And the invalidation of cache is actually quite complicated. By the way, it can be solved. So the cache invalidation can be solved if you have events, because then you say, okay, we invalidate the cache whenever the events happen. So actually this is solved. But you have to be sure that you have all the data changes under control. So the events, then they can come together with read models also. Yeah, and that's the techniques that I have seen working. But the infection, that people have in mind is very deep. So, the vaccination is also important. Okay, at some point we need to agree that, for example, when you review the pull request or something, that okay, but we need to agree at team level that we are, whenever we can, we rely on events instead of callbacks in active records, for example. So let's try at least not to deepen the infection. Let's try to, with the new situations, let's use the healthier approach. So it's like getting on a modularity diet, basically.
Yeah, I really like the habit building thing or idea that I guess started with just publishing the events, even if you don't do anything with them, and then introduce low risk and maybe low criticality kind of functionality, notifications maybe, or something like that, where you're not actually in danger of breaking the application, but you're adding some value, but not changing the actual structure and important critical application structure of the code. So I think the habit is probably, or developing that's really important. And like you said, at least in the beginning, you were referring to the business people if in their vocabulary they have the CRUD language that is bad, and that's maybe one way of curing them also from that, because CRUD is just an implementation detail that has crept into the business lingo, wouldn't you say? So if you can remove that by introducing events and getting the when we're discussing the problem and the domain and how things happen there, like in natural world, we shouldn't be concerned how the framework or the library or the programmers might go about implementing something. So I think that's a really useful insight of trying to build habits, and by using slow steps or small steps to get there. So what would be like the more advanced concepts that if you think about if I'm a software architect and I think that I'm at the level that I understand the basics really well, and what would you be saying, and I've been practicing it a little bit. What are the new cool things on or the advanced concepts in this realm that first of all interest you and you're passionate about, maybe other people should also look into?
The two topics that I was recently experimenting with and introducing in some of our projects, one is deeply related to event sourcing, and it's called bitemporal event sourcing. It's a complicated name, but once you get the idea of events, and we use the price change event, so let's stick to this. We assumed implicitly that when we publish a price change event, we mean changing the price now. This is happening now. So bitemporal event sourcing is about introducing more dates or more date times to the semantic of the event, which means very often, especially in accounting software, but actually it's in very, even in e-commerce, you can say, I was actually doing this recently. I have this open source e-commerce project. It's only for educational purpose. So I'm trying to implement many different scenarios, how to do it in the event-driven way with domain-driven design, with read models and stuff. And I came up with this requirement actually based on the Arkency needs. So Arkency, we sell books, we sell courses. And sometimes on Black Friday, we reduce prices, right? And Black Friday is basically some few days where the prices are lower. And the typical way we are using some kind of e-commerce platform is to basically say that, enter the shop and say that the product now will be changed. The price of the product will change now. So there's quite a lot of manual work because you want to select which products, and you have to be actually at this moment of time to change it. What we want to do is to automate it. So you want to schedule a campaign of changing prices. So let's call it a Black Friday campaign. And ideally in our system under the hood in the implementation, we want to say, okay, the price will be changed instead of the price changed. And you can implement it with a new event, like the price will be changed, let's say, but it sounds weird. Events should be always in past tense. That's very important.
That's what I was about to ask you, your opinion on that.
It's a fact. Yeah. There are other ideas how to implement a price change in the future. Like, for example, another approach is, which also we tried, but in other scenarios, it could be scheduling a command in the future. So you want to say, I'm creating a command called change price, but I want this to happen in 3 days from now. So there will be a very specific date. And then you have some kind of sidekick-based or some cron-based mechanism, which will say, okay, at this time, I will wake up and run this command because that was scheduled for this time. So you have some tooling for that, which would be fine. But another part of this requirement of changing prices for the future is that I would like to actually see in the admin panel that there is a scheduled price change. I want to see this. I want to see it on the product page on the admin that in 3 days the price will go up or down. And with the sending the commands to the future, that's not easy, because your read models, they shouldn't consume commands. They should consume events. So by elimination, there is I came to this solution using. Obviously, I didn't invent bitemporal event sourcing. There are smarter people than me who invented this ways many years ago. It's actually, in general, in accounting, you have this double time bookkeeping. The idea that you have two concepts of time. So one is when the change actually happened and when it is reported. So even in accounting, you have this idea, okay, in general, you don't go back in time. In general, you don't book stuff which happened 1 year ago. But in actual practice, you do this. And you say, 1 year ago, this order happened. We reported today, but somehow we missed it. And we have to deal with this business situation somehow. Again, many other ways than just bitemporal, but one way would be to say, using bitemporal event sourcing, you would publish an event and say, an order has happened with those items, but the date was, 1 year ago. And then let the read models decide what they do about it. So let the read models decide what is happening actually. How do they interpret it? So the kind of price of this approach is that now, and actually I had to pay this price in a way, because now if you introduce the bitemporal event sourcing, the semantic of an event changes. Now it has a different meaning because a new attribute was added, and we call it valid from or valid at. And then you need to review all the places where the events was consumed. So usually it's read models, but sometimes it's process managers. We can go to process managers later. And you have to think, okay, does it change? What do I need to do with this specific part? And this is actually the cool part of modularity based on events, because now you know exactly which places consume this event, and you can analyze them each one by one and think, okay, on this page, do I care about the new price in the future? So for the admin product page, yes. For the public product page, no. And by the way, when I remember when I implemented a separate read model for admin product page and for the product page, I remember someone was telling me, Andrzej, but this is too far. This is like, okay, you are now denormalizing for the sake of denormalizing, right? Because the product page on the admin is just presented differently, but it's the same. But then if you come up with this, more fancy scenarios, then actually you see, okay, the admin actually has different information and you want to present them while the public shouldn't know about this. So you don't even want to, it's not about hiding information. It should be a security, even this read model modularization idea, it's also a security idea, because then it's never part of the data that this read model accesses. There's never a risk, following certain discipline, there's never a risk that this read model exposes some data accidentally. That's a security by design. So you review the read models where the event was introduced and you have to change them. And in our case, even in this e-commerce educational project, that was some number of places where it needed to be changed, and we needed to get this into account that the product price will change in the future. But now we have it working, and the price, we have this price. The event is called price set. And thanks to this, actually, even some previous features which were implemented without bitemporal event sourcing, so without this new date, new timestamp, they can be now refactored to this. So I will do it very soon, probably. I will turn some of the existing code, and I will remove quite a lot of code, because now certain, we've had a concept of happy hour implementation, for example. So we've had a concept where we implemented this abstraction of happy hour. It's called happy hour, but it can be also 2 days of a change price. So also some way of changing the price for a specific time. But here it was with the beginning and the end, and this was implemented differently. So it was happy hour created, or happy hour registered, happy hour activated, and so on. And now it's actually all reduced to just price set, one date, price set different. So you can say, okay, let's schedule a price change to start the Black Friday campaign and another one for the end of the Black Friday campaign. And there's just 2 price set events with different dates. And that's it. That's the implementation of this feature now. So quite a lot can be simplified. So this is one example of using bitemporal event sourcing. Some real world scenarios which are typical for bitemporal is, for example, when you negotiate a salary change or a rate change with your employee, that's a bit temporal in practice, right? You negotiate today that you will raise the rate, the salary by 5%, but it will be applied in practice on the 1st of July, right? So this is bitemporal. This is bitemporal in practice. So it's very useful because in many business, in many softwares and many business, you have the concept of time. Actually, I think in all of them, and you can now start introducing this high-level way of thinking about time and change the semantics of the events, and then solve some problems in the code base this way. And by the way, when I review existing projects, usually the time handling is very convoluted. Like everyone just can anywhere access date.now or time.now. And in test, they will use some time cop or something like this in the case of Rails projects. But there's the time management is not really modularized. And by the way, calendar is a nice domain name. Calendar is a nice way of representing the time in our system as a domain, as a bounded context. And you can publish events like day passed or week passed or month passed. And then certain areas in your system can actually react to it, because you may have some business scenarios where something has to happen 3 days after price was changed, or something has to happen 3 days after user was registered. And then you can create this flow of the happenings using the calendar events. And then we can talk about process managers somewhere in this area.
Yeah. Well, that's an interesting insight. I probably personally have to a little bit process what that will mean or the possibilities that will open, but that's a really useful insight of thinking calendars as a one bounded context. Well, at some point during the conversation, you did mention you covered quite a bit of different concepts, or maybe you could say objects in this problem domain. You mentioned bounded context, you mentioned process managers, and I'm curious to hear what do you mean by process managers and how do you apply them in, for example, domain-driven design or event-driven architectures?
Yeah, I can explain it from the technical level and from the business level. I think those can be matched. From the technical level, a process manager in the domain-driven design architecture is a way of saying whenever certain events happen, we want to send a command to another domain to make a change in the system. So typically you will have the submit scenario. So you want to deliver the submit order scenario. So you want to deliver the order only when it's paid, when we have the address where to deliver, when the invoice maybe was generated. So there's certain requirements, and then you can say, okay, delivery domain, please deliver this order. So you have a process manager, which is something like long running. So basically it reacts to events. So it kind of subscribes to this, order paid event, but it kind of wakes up because it subscribes to order paid, and order paid happens. So it wakes up and says, okay, nice, order paid happens, but let me look at other information about this order. Well, we still don't have the delivery address. So I'm not doing anything else. I'm just collecting and persisting the information. Technically, I'm linking this event to my stream. And that's how we group events under the hood. So read model can have its own stream, process manager can have its own stream. So I'm linking this order paid event, but no, the requirements are not fulfilled. I'm not fulfilling the order, not delivering the order. But then delivery address provided event comes. And this process manager, this delivery process manager wakes up and says, okay, I have order paid, I have delivery, I have everything else. Good, I'm good to go. I will send the command to be handled. So I'll send the command called delivery.deliver, or whatever is the right name for that, with the ID and stuff. So it's activating this delivery process, right? This delivery scenario. And now the process manager is over. For this order ID, the process manager of delivering, it's over. It can be more complicated. Well, all the refund scenarios are usually fun at e-commerces. So you can have more complex scenarios that, okay, we have activated the delivery, but for some reason the user refunded now in the meanwhile. So you still have to do something about it. So maybe you want to say, you want to react to refunded event or canceled order event, and you want to still go to delivery and say, hey guys, maybe you can cancel it somehow. Like maybe the cars didn't go, maybe the courier didn't provide the package, didn't really go with the package. So do whatever you can because we are canceling this. Or maybe if it was already delivered, maybe you need to start a new procedure for getting it back, right? So because they will, maybe you use some kind of courier service or something, or delivery service. So those are process managers. Those are process managers at the technical level. So events as input, command as output. So you can see how much you can go, how far you can go with the algebra of events and commands. Read models was events as input, data structures output, domain. Like, okay, we didn't talk much about aggregates, but this is a very simple objects where they need to just check whether they are reacting to a command. So command is an input, event is an output. So basically they're saying, well, I'm about to change the price of a product. Changing the price of a product usually doesn't really have any real business rules. So basically, okay, we will allow, well, I will publish the product price changed event because that's basic. Sometimes there are state machines where you need to ensure, okay, I need to be in this state in order for the product to be, the price to be changed. So quite a lot is about the algebra of events and commands and some kind of data structure at the end. And from the business perspective, so that was the technical perspective at the processes. And this is the classical domain-driven design explanation which I provided. At the business perspective, business people, they think about departments. They like to think about splitting responsibilities into different teams. And that's how business structures are created. When companies grow, it's important to split responsibilities and so on. So at the business level, you can imagine that you have separated departments. Obviously, at the human level, they are talking to each other. But at the process level, ideally, there shouldn't be like some kind of chaos. So the marketing people, they shouldn't run into the sales room and tell them what to do, or the sales people shouldn't run into marketing room and tell them what to do. It's like this communication should be somehow structured. So the communication between departments needs to be somewhat structured. And I think this is more or less where the uniqueness of a business comes into place. So each business has marketing department, each business has sales department, each business has invoicing department. How they communicate with each other, this is where the fun starts, because every business can be different here. You may want to optimize for certain things. You may want to be, the invoices to be like super quickly generated, and that's for some reason in this business is important. You may want to deliver super fast, so the delivery should be like the focus, like everything is about delivery. Or you may want to have lowest prices, so the pricing is like the always looking at competitor prices, and the pricing domain is all about always being lower than the competitors, for example. So at the business level, the processes is basically any kind of interaction between departments for a specific purpose. So, for example, this pricing competitiveness process. So you want to always be ahead of your competitor. When they lower price, you lower the price. Let's say you have this business rule. Then you have some kind of mechanism for grabbing their price. You web scrap their pages, whatever. Someone calls you and say that the price was lower. So you have some code to run this, and it results in certain information that the competitor price for this product is lower. And then you can react. So actually, this will be reactions within the same department. So maybe that's not like perfect example, but still it's kind of a reaction. So an event happened. So we'll say a command, reduce our price. And the process manager is like a automatic way. So it's a way of the system reacting to itself to do some change because something already has happened. Between different departments, so the order fulfillment scenario, the delivery of the order, it can be seen at the business level as some kind of cooperation between the departments. So we want to say, anyone noticed that, the payment, so you can have less automated business where payments are not really part of the system. So you can have someone, a human person, getting notification from the bank that we got a payment for this order, and they will notify, they will notify that this has happened. So that's the business perspective. Even without having a software, the business thinks this way. The business is structured this way, that you have departments, you have roles, and you have some kind of communication between them. So the departments and the events, just the names of the events, the schema of the events, this is like the static structure of the business. But the way how people, like who reacts to what, I would say is the dynamic structure of the system. So this is like the living system, the business, how it behaves runtime, regardless of whether it has a system to support it or it's all human based. So this is the processes at the business level.
Would you say that the now this thought came into my mind, and about everything that we discussed so far, but mainly maybe focusing on the process managers. If you have this kind of a separation of concerns and structure of your business software, would you say that you'd actually be very adapt to change? Because you're now only concerned about maybe a certain event, the surprise change. So now if you want to modify the behavior of the whole system, which is your business, by simply modifying how you handle that event, you in fact change your entire business from the software perspective. So it gives you kind of a exceptional agility in terms of modifying your tools and supporting software to drive your business the way you want it.
I think that's exactly what we achieve here. I think that's exactly what's possible here. I know this is kind of a dream scenario, and you never really get to this amazing nirvana point where everything is like super adaptive, but it's real. It's you don't have to turn all your code base into events. The idea is actually to find, what is my most changing business area? Usually it's the core, we call it the core domain. So at least have this area to be covered by events and commands, have this algebra, because then those are the areas where things might change more often and you have to be adaptive most often. So if you have like priorities, I would focus on the core. And then you can actually have this very adaptive system. I'm a very idealistic person in general, but this is the practical approach. So at least have this core domain to be covered, because the programmers can react. The idealistic part of me and my future thinking is like, you can imagine that because if you look at the process managers code, and the process managers are usually the heart of the system, the actual flow of data, the flow of money, and so on. It can be implemented very declaratively. It's basically when this, and this happens, do this. It's possible to implement it like this. You can hide the implementation details, like, the linking of the events to the stream. This is like a low-level part. You can hide it. So you will have 20, 30, 40 processes being captured as very simple classes, objects, maybe functions, because it's actual function, right? It's given this input of events, you will output a command. If you do it maybe you can show it to the business people, because maybe they understand, this is our pricing competition process being implemented. When the price of the competitor was lower, we reduce our price to be 1 cent lower. And when they see the name, when they see the event, which are almost like English sentences, and the commands, which are also almost like English sentences, it's in their capabilities to understand it. And maybe that's far future thinking. Maybe it's in their capabilities to change it as well.
Interesting. Yeah. One thing about the publishing the events that came to mind. You probably have examples of this, like really good examples of that. But what I personally found is that you should publish, or what my experience with publishing events has been, is that when I begin publishing it, maybe for just to have them available, and maybe I have some small requirements that events that I want to react, or some changes to do in the business. But later on down the line, maybe that's 3 months, 6 months down the line, a new requirement pops up, and just by having the events, I can fulfill the requirement right away. Usually, I have the like the history data. I have because usually it's something that, do we know when this thing happened, or how many of these events or actions did take place in our business. That's like a typical use case that I've seen, where just having the event repository handy will get me like 80 to 90% of there in terms of meeting that new requirement.
That's true.
Do you get what I mean? Do you have any like really good examples from your own personal experience that I can see, or the clients that you've helped, where this kind of like unexpected value would come from the events that you maybe maybe not for you, but for like a beginning DDD and event sourcing practitioner, you suddenly discovered these benefits that you didn't think of, that you get from by simply just publishing the events.
Yeah, actually, it's very, very common and very often. Even our recent scenario was in one of the big projects we worked on. There was a need to rework the registration part of the users, which is a very basic. In every race application, you have the very, very, very basic pages for that. And there was a dilemma. Okay, from the cost perspective, does it make sense to make this area also event-driven? Because this is one of the areas where you can debate. Maybe it's not worth it. But if you have a team which is capable of introducing events, adding the events is like almost like no time necessary. You just create an event class, you publish it, that's it.
Yeah.
So we did that this way quite quickly. And almost like the next day, there was a new requirement coming about the registration area. So we've had those events around the registration. Some of the events were already used in some process managers, because the user registered event is like the huge event, which is actually very useful to have. Some of them, like, I don't know, user login changed, maybe it's never really used, so maybe you don't have to be so granular. And we've had like some way of activating the user based on what info they provided by their registration. So we kind of treated them a little bit differently in terms of this onboarding scenario. So onboarding of the user, we wanted to show them some kind of different screens based on the fact whether they are a big company or small company. And so immediately we could implement it without adding new events, because all of the events were already there, because the question about the big, small was already there. And we just implemented a new read model flow based on this information, right? So we just show them a different onboarding pages. And basically it was like, 10 minutes of work to do this change. And I think that was thanks to events being there. There are other scenarios where, for example, we talked about this price changed event, and maybe this is not like super often this requirement, but we've had this one project where we were asked to implement or actually there was a new requirement. So there is this new EU regulation where if you run a promotion and you lower the price, you have to show what was the lowest price in the previous 30 days. So they want to limit the kind of, manipulation that is actually not really a price change. So there's this regulation. I think it's called Omnibus. And implementing this actually requires you to have the history of your prices. And in typical CRUD approach, usually you don't have this.
Exactly.
Usually you just modify the price attribute on the column. So sometimes people implement prices as the new table, but usually most of the implementation I've seen is basically products table and price as a column, and that's it. So introducing Omnibus, for example, I was consulting with some projects. So implementing this Omnibus directive from EU, which was regulated, so it was necessary legal work. For some of the projects I've seen from distance, it was like almost months of work because it wasn't so easy to display the price from the previous 30 days. And you know how old systems, they can be so ugly below the, it's not so, like you can see, okay, this is just a price, but under the hood, it was like some kind of a mess. Okay, normal project still should be able to implement this kind of thing easily, but still you have to, if you don't follow the events, now you have to introduce the prices table, and then the prices will have timestamps. And now on all the new places, you will have the new join to be made, because now you will have the price table to be joined. So many reports, which are already slow, will become even more slow, right? So now you're deeper in the problem of performance, but also deeper in the problem of complexity. And with events, that's again in our e-commerce implementation, we have this the Omnibus direction implemented. I don't know, like, because that was someone else contributed this, because it's an open source project. I'm not sure how much time they needed, but the code actually was, it was easy to check, imagine, okay, this is the way it works because of events. So yeah, there are many different scenarios where the events come handy, that you actually collected the data from the past, and because in the CRUD approach loses data by design. That's the funny thing.
It does, yes.
And you never know when it's needed. Maybe you can access backups, but this is not very useful, like not very comfortable to do it.
Yeah, the event, using publishing events, it gives you the audit log for free, basically. Yes. So that is really, really useful. Not just in a situation like this. In your example, having to implement some regulation requirements, but also, like, for example, in security incidents, you might be able to go back and see who did what and when and with which data, if that's something that is part of the events that were involved or caused the security incident. So that is a big feature that you get for free.
Exactly.
By just starting publishing events, yeah.
And again, like, for example, with our Rails event store, you get this audit log completely for free because the UI is already built. Mm-hmm. So it's really, you can traverse it. And here also another situation comes to my mind from another project where we had to implement, and it's very typical for web projects, where you want to implement the impersonification feature. So you want the customer support people or the admin people to log in as someone else without knowing their password and so on. So in many projects, we implemented the impersonification. And with events, it also works quite well. It's very similar to the bitemporal event sourcing, but it's not about times this time. It's about a new kind of metadata for this event, where you say impersonated by. So you just add to all the events which are happening under certain code flow. And with Rails Event Store, we give you this like helper that whenever you are impersonificated, we will append to the events which are happening in the flow of this request. We will append a new metadata attribute called impersonificated by. And this way, in the audit log, you can see, okay, the user did the action for themselves this, but then the admin logged them as there, and maybe he did some actions. So it's, for some systems like fintech systems, it's very important that you have to capture those moments, and you have to know that that this was done by someone else, or the customer support people, because that's still important that they are able to log in as the users and do something for them. But it's important from the auditing perspective that we know this. And it's not easy to implement without events. And here it's just a new metadata attribute of the event. So it's becoming quite easy then.
Yeah. No, I can imagine like other scenarios where you'd want to maybe help out the user debug something that they're having trouble with their account, maybe using some other features. And when you're impersonating, you might perform actions that are doing the things or triggering stuff or triggering commands that the user would normally do. But since your handlers know that they are impersonated, maybe they don't execute them. So you actually don't make the changes in their account and so forth. But the customer support can still like verify whether the control flow works appropriately, and do they see the events in the application when performing an action as this user. Is it the bug in the system, or is this where I need to educate the user? So this is how you use the system. So
Exactly.
yeah, that's very interesting example.
And even from the UI perspective, the impersonification requirement usually comes with this idea that the admin or the customer support person, they should somehow be reminded that they are logged in as someone else, that they are now impersonificating. So again, with read models, it's very easy. You're reacting to an event that, okay, the impersonification started, and just show, I don't know, red bar around the whole screen, and you say, hey, you are now reminder, alert, you are now doing this. Just to remind them, because there are many security issues with impersonification, and one of them is that people can forget to log out.
Yeah.
And then it leads to troubles later on.
Yeah, well, now that we start winding this conversation down a little bit, what would be, let's say, a audience members be listening to this and they're really into learning more about all the topics that we covered, or at least in the DDD realm and maybe event sourcing. What would be your top 3 things that you kind of covered from the implementation side of things, like starting publishing events and then having the event storming session, but maybe for those who are not what these concepts aren't yet very familiar for them, what would be like your go-to resources that you recommend people to get started with?
It depends from which area it seems to be attractive for them. So domain-driven design, obviously, there is a blue book from Eric Evans. Actually, it's here on my shelf. So domain-driven design book is for understanding the idea of splitting your domain code into domains. So that's the book is great. Also, some tactical patterns like how to implement value objects and stuff. This is useful. So that's one good starting point. It's a classic. So people in domain-driven design community would say it's expected at some point to read at least part of the book. However, the book is not also super easy to consume. So you have to assume that it will take you 3 months to read this book. It's not. It does take some time. If you are more looking at this from the code perspective, you are this person where you really want to see the code. I think the project that I started, the e-commerce one, we can link to this, is a really good example. Okay, it's in Ruby, it's in Rails, but I'm showing how this, the project is completely uninfected from Rails. So all the domain code doesn't live in the directory where the Rails application lives. So there are many concepts. I think that there are some, every module has a small README, so you can understand at least the flow. There are some links in the README also, which can lead you to some YouTube videos where I explain certain parts better. And it's all at this level, it's all free. Also Arkency blog, so blog.arkency.com. I think we blogged about every possible topic we mentioned here in this conversation. So you can just go to the main page and just search for the keywords you're interested in, and you will find lots of free resources. From the ideological perspective, Greg Young lectures about CQRS. He has some lectures from the past. They might seem old now because they are from 10 years ago, but they are super, super relevant, and it's it doesn't age badly. It really age really, really well. And he's a very entertaining speaker as well. So I think Greg Young on YouTube has many good videos. Obviously, if you are from Rails, then we have this Rails Architect Masterclass where, this is a paid material, but it's quite big and I think very extensive with all the topics provided. But that's specifically for Rails mostly. In the blog Arkency, we also target like mostly Rails people, but the topics are generic, right? So we just use Rails mostly because we use Rails, but it's very generic, and you probably use Python or Java or .NET. You will have slightly less API maybe. Also look at the possible event stores that are available in your technology. In Rails, we have Rails Event Store. So Greg Young was the initial creator of the Event Store DB. So that's like a separate event database. Rails Event Store is relying on your existing database. Event Store DB is like a separate database for events. Yeah, so the documentation provided with those toolings. So Python, actually in Python, there is a group of people working on kind of like almost like a port of Rails Event Store to Python because they like the design of the Rails Event Store. So I know there is some work being done in this area. There was a Django Event Store, I think, but I'm not sure how far it went. It was also inspired by Rails Event Store. Yeah, in Java there's I think Axum or something like this. There's a number of choices here, so you can probably Google that and find some communities around it and see what kind of examples they provide. I'm focused. This is my current work and current focus. I'm focused on this e-commerce project where I want to show the whole project from beginning to end, how to implement e-commerce. And even if you're not working on e-commerce, many projects are e-commerce because they have pricing, they have the concept of ordering, because you are selling something in the end. So usually all the projects are, even if you work on an insurance project, you're selling insurances, you are in e-commerce in a way. So that's why I chose insurance as the base for this work. And you can see how UI is built, for example. Probably don't want to go into so much details about Rails UIs, but we use the concept of hotwire. So we are not using JSONs, we are using the Rails views, the HTML views being rendered on the server, and then using WebSockets with hotwire, we send them to update the client. So you can see that when an event happens, the read models are changed, and then the read models also are responsible for this WebSocket communication. So we have it this way that, okay, read model is responsible for everything around, showing this to the user. So we are using the Hotwire API to just say, okay, we now update the page immediately. So whenever there's a change and someone has a tab open, it will has almost like the JavaScript effect. But with Hotwire, you don't have to write JavaScript. So in our case, it's all Ruby.
Yeah, well, I will definitely link to the e-commerce repo that you guys have created, and that's truly a fantastic resource in a sense that it's not a trivial example. It's a full-fledged application and the whole domain while it's e-commerce, but it's modeled. You got all the different modules there, and personally, I've spent a lot of time in that repo just reading about, seeing how you've structured the modules and how do you publish commands and how the aggregates are built and process managers and everything. So it truly is a really valuable resource when you want to learn. And really thank you for building such a thing. It must have been quite an effort, but it's a very valuable learning resource. And while it's in Ruby. And there might be developers who do not have never written a single line of Ruby. You've, as you said, you've documented it well, and it's in what would be the right word? It's in a format that definitely will be easy for any developer, regardless of their language, to follow along. Because, as you said, it doesn't have the whole domain part of it has no dependency on Rails, and you really truly just watching, like you said, the business people when they are looking at the code, they can start seeing familiar event names and they can potentially make out what's happening. So I believe for any developer, just by reading through the code, they can get a grasp of what we talked today and kind of understand how such a system with this approach can be structured. So that's a really, really valuable resource. And again, I can also vouch for the blog that you guys write. As you said, even though you use Rails as an example, the articles are more about the technical concept of the idea, not so much concerned with the implementation details. And so highly recommend that as well for anybody interested in this area.
Cool. I'm happy that you found the e-commerce project useful for you. So thank you.
All right. So I think that's a good place to wrap it up today. So Andrzej, thanks so much for coming along and explaining a lot of cool and some of them a bit advanced concepts, but I believe that for many, regardless of their experience with the DDD or CQRS or event-driven architectures, they probably got quite a bit out of it, and hopefully pique the curiosities to learn more and explore the paradigm and the ideas, even though they would never use them. So because I think by exposing yourself to a lot of new ideas gives you also helps you become better at what you do currently and what you're good at this moment. So I really enjoyed this conversation, and thanks for coming on Dialogue.
Yeah, it was a pleasure for me as well. So thank you for inviting me, and for the audience, it's a fun journey to take to start it. It might take you years to enjoy, and a really long-term investment, I would say. So I think it's worth trying.